Hello, and welcome to our little corner on the web, where we hope to develop and nurture a love for math. Today, we'll go over questions 12 and 13 in part 1 of the 25th PMO Qualifying Stage paper. Okay. I'm flashing the two questions here for now so that those of you who want to try it first before looking at one potential solution can do so. Question 12 is more number theory algebra type. And I guess question 13 is also similar. Okay, so you may pause here and give the questions a try first. Okay, diving into question 12. Okay, question 12 asks, a 5-digit perfect square number, A, B, C, D, E, with A and D both non-zero, is such that the 2-digit number DE divides the 3-digit number ABC. If DE is also a perfect square, what is the largest possible of ABC divided by DE? Okay, so we know that DE is a perfect square, so we can try to write DE as a sum n squared. This means that if ABC is divisible by DE, ABC over DE is equal to some K, or ABC can be expressed as n squared K. Okay. So we can also write the whole 5-digit string, ABCDE, now as 100 times n squared K plus n squared, right? Meaning ABC is now multiplied by 100, this ABC here, okay? And then we add DE. Okay. So we know that that is also equal to some other perfect square, m squared. Okay. So we can write m squared as n squared times 100K plus 1. And we know that because n squared is a perfect square, then 100K plus 1 must also be some other perfect square. So a squared equals 100K plus 1. At this point, you can actually make the choices work for you, and you will find that both 2601 and 2401 are perfect squares. And since we're looking for the largest possible value of ABC over DE, then K equals 26 is the answer. But I want to push it a little further into saying, what would you do if this was a short answer question and you couldn't just basically, try the choices? So here, what you would actually do is transpose the 1. So you have a squared minus 1 equals 100K, or a plus 1 times a minus 1 equals 100 times K. So we know that K cannot be more than a 2-digit number. So one possibility for K that's sort of obvious is K equals 98. If you try plugging that back in, you'll find that you get a 6-digit number instead of a 5-digit number. So now the question is, how can we split the factors of 100K into something that might be a little bit more appropriate? And one way to actually do that is to do 50 times 2K, in which case 2 more values of K come up, which is K equals 26, which makes it 50 and 52, or K equals 24. And that's where you sort of can now test 26 and 24 to find out that the answer is 2601, which is 51 squared. So the answer here is D, 26. Okay. Moving on to the next question here. Okay. Question 13. Consider the sequence A sub n, where A1 is equal to 1, and for n greater than or equal to 2, we have A sub n equals n raised to the a sub n minus 1. What is the remainder when a sub 2022 is divided by 23? Okay. For questions like this, I tend to try to find the form of an first. If we can find a nicer way to represent it than what is given here. So first I tried a1. We're given that's 1. a2, a sub 2 is equal to 2 to the 1, which is 2. a3 is 3 to the a sub 2, so 3 squared, which is 9. A sub 4 is 4 to the a sub 3, so 4 to the 3 to the 2. And here's where I realized that a sub 2022 actually just follows a pattern. So a sub 2022 is this like mountain of a exponential 2022 2022 to raise to the 2021, raise to the 2020, all the way to 1. So this thing is what we're dealing with, this thing here. Okay. And we want to see what the remainder is when divided by 23. So really, we wanted mod 23. So one thing we will use here is, or two things actually, is Fermat's little theorem. Okay. Which states that a to the phi of n is congruent to 1 mod n. So you might also ask what's phi of n. Phi of n is Euler's totem function. Which gives the number of coprimes that n has. Okay. Okay. So we know that we can reduce 2022, meaning we divide 2022 by 23, we can get that remainder, and we can reduce this a sub 2022 mod 23 into something a little simpler. Okay, so let me just make some space here. So those are the two things that we'll use here if you want to look it up on your own. But I'll need that space, sort of whiteboard space, to continue working. Okay. So now we can sort of reduce a sub 2022 into the remainder of 2022 mod 23, which is 21. So this is equivalent to saying this is 21 raised to the 2021 to the 2020 ... mod 23. Okay. So that's the first simplification we're doing. And then we know, as I said a while ago, that a number mod 23, since mod 23 is prime, so we know that whatever number that is, raised to the 22 is congruent to 1 mod 23. So we will divide 2021 by 22, okay, and get the remainder. The remainder is 19. Okay, this remainder is 19. Okay. So we can further reduce this expression to 21, okay, raised to the 19, raised to the 2020, 2019, ... mod 23. Okay. So remember, we did mod 22 on this, or we did mod 22 on that. So now we can actually look at the things above it, okay, and we can do phi of 22, okay, phi of 22, which is 10. Okay, if you're wondering how to do it, P of 22 is no more than the prime factors, or at least involves the prime factors, 1 minus a half. This is the 2. 1 minus 1 over 11 times 22. Okay, so that gives you a half times 10 over 11 times 22, or phi of 22 is 10. Okay, again, I encourage you to look it up. We won't be able to go through the whole thing here, but that means that this whatever expression is below, if this is raised to some subset of some groupings of 10, it will just give us remainder of basically 1, right? So, but 20 is divisible by 10. So actually, this whole thing just reduces to 21 raised to the 19 raised to the 0. So anything else above that actually didn't matter. Okay, so this thing mod 23 just reduces to 21 raised to the 1 mod 23 or 21. Okay, so the answer here is C, 21. Okay, hopefully that makes sense. In all honesty, I was surprised to see this as a qualifying level questions, but I would encourage you all to read up on Fermat's little theorem and Euler's totient function. Okay, so hopefully you found these solutions useful and educational, and good luck on the PMO. Thank you for watching.